Hello and welcome to helpyourmath.com. In this video, we're going to look at writing equations of circles in standard form by completing the square. And I expect you to already know how to complete the square when you watch this video, so if you need to review that, please go back and watch the video on completing the square. Let's get started. So first, what is standard form for a circle? That would be x minus h quantity squared plus y minus k quantity squared equals r squared, where hk is the center of the circle and r is the radius. Okay, here's the equation we're given. X squared plus y squared plus 4x minus 6y minus 3 is equal to 0. I'm going to go ahead and start by kind of grouping together the x terms, grouping together the y terms, and moving the constant to the right-hand side. So I have an x squared and a 4x. I'm going to say x squared. Now I can't actually add these because they're not like terms. And then what I'm going to do is I'm going to leave a space here. I know I'm going to be adding something to it. I just don't know what yet. And now I'm going to do the same thing with my y squared. So I have y squared and minus 6y. And I'm going to leave a space here. I know I'm going to add something. I just don't know what yet. And I'm going to add 3 to both sides just to move that 3 to the right-hand side. That is an optional step, but I just wanted to sort of take the form of standard formula because I can. Okay, so now we have x squared plus 4x plus something should be a perfect square trinomial, because that's what we need to do, is we need to get x to be some single root quantity squared. So do you remember how we figure out that third term? Well, we take the middle coefficient, which is the 4, we divide it by 2, that gives me 2, and then we take that and we square it. 2 squared is 4, so I need to add 4 to create a perfect square trinomial with the x terms. Now I can't just add 4 to the left-hand side without doing something else. So if I add 4 to the left-hand side, I also want to add 4 to the right-hand side. Okay, now let's look at our y terms. We have y squared minus 6y. I need to add something so that that becomes a perfect square trinomial of the form y minus k quantity squared. So what do? We take that middle coefficient, minus 6, we divide it by 2, that gives me negative 3, and we square negative 3 to figure out that missing third term. Negative 3 squared is 9. So I'm going to add 9 to the left-hand side, and I need to add 9 to the right-hand side as well. So now we have, x squared plus 4x plus 4, we're going to rewrite as x plus 2 quantity squared, plus, and then the y's, we have y minus 3 quantity squared is equal to 2 plus 4 is 7 plus 9 is 16. So this would be the equation in standard form, and now we can pretty quickly identify, it didn't ask us to do this, but we can pretty quickly identify the center is negative 2, positive 3, and the radius is the square root of 16, which is 4. Okay, how about this example? We have x squared plus y squared minus 10x plus 8y plus 5 is equal to 0. So first thing, again, I'm going to put all my x terms together, so it's going to be x squared minus 10x. I'm going to leave a little gap here, and then I'm going to do my y terms. I have y squared plus 8y, and I'm going to leave a little gap, and I'm going to subtract 5 from both sides, and I end up with equals negative 5. Now you might be saying, wait a minute, that right-hand side can't be negative because it's going to be a radius square, but we're not done yet, right? We're still going to be adding things to that side, so presumably we're not going to run into a problem. Starting with the x's, what do I need so that x squared minus 10x is the first 2/3 of a perfect square trinomial? Take negative 10, divide it by 2. We end up with negative 5, and negative 5 squared is 25. So for this to become a perfect square trinomial, we need to add 25 to it. If I add 25 to the left-hand side, I'm going to add 25 to the right-hand side. We're not going to have a negative anymore. Okay, how about with my y's? I have y squared plus 8y. What do we need to add to this so that we have a perfect square trinomial? Take that middle coefficient, divide it in half. That gives me 4, and then square that so that we know what that third term is going to be. 4 squared is 16, so I need to add 16 to the left-hand side, and therefore I need to add 16 to the right-hand side as well. Now I have two perfect square trinomials. X squared minus 10x plus 25 will factor into x minus 5 quantity squared, plus y squared plus 8y plus 16 will factor into y plus 4 quantity squared. And over here we have negative 5 plus 25 is 20, and 20 plus 16 is 36. And just in case you know how to complete the square, but you're just forgetting, where am I getting the minus 5 and the plus 4 from? It was right here when we took that middle term and divided by 2. That's going to tell us what the root is, or what that second part of the binomial should be. So it's the minus 5 from there and the 4 from there. And this would be the equation of the circle. We now can quickly figure out that the center of the circle is located at 5, negative 4. And this one has a radius of the square root of 36, which would be 6. In our last example, I see a problem right off the bat. X squared and y squared should not have coefficients. Luckily, they have the same coefficient, so that indicates to me I'm going to have to divide everything by that coefficient so that we end up with just x squared and just y squared. They both have coefficients of 2, so I'm dividing every single term by 2. Divide by 2, divide by 2, divide by 2. We'll divide 0 by 2, but that's actually not going to do anything. That's going to give me x squared plus y squared minus 16x plus 6y plus 30 is equal to 0. Now I'm ready to get started. So first I'm going to group my x's together. That's going to be x squared minus 16x. I'm going to leave a little gap here. Start my y's right here. Y squared plus 6y. Leave a little gap. And I'm going to subtract 30 from both sides. Ooh, 30 is kind of a big number. I hope this works out. Let's see. With our x's, so x squared minus 16x is 2/3 of a perfect square trinomial. What's that third? First, we're going to figure out what the root is. The second root is going to be negative 16 divided by 2. So I know the second root is negative 8. Then I take negative 8 and I square it, which gives me 64. So I need to add 64 here. So that x squared minus 16x plus 64 is a perfect square trinomial. I added 64 to the left. I need to add 64 to the right as well. Okay, now for y squared. I have y squared plus 6y plus what is a perfect square trinomial? Take this middle coefficient, divide it by 2. 6 over 2 is 3. Square 3, and we end up, so we need 9. So if I add 9 to this, y squared plus 6y plus 9 is a perfect square trinomial. I add 9 to the right as well. Okay, now we're ready to write the equation of the circle in standard form. This would be, let's see, it's going to be x minus 8 is the root of x squared minus 16x plus 64. X minus 8, quantity squared. Plus we have y plus 3 quantity squared is equal to, this is 34, and 34 plus 9 is 43. And again, all it asked for was the equation in standard form, but if you wanted to, you could figure out that the center of the circle is located at 8, negative 3. And we have a radius here of the square root of 43. These have been examples of writing equations of circles in standard form using completing the square. Thank you for stopping by.